Let's look at a real world scenario here. I know the Olympics are over, and but when I think of Olympics, sometimes I think of running, 100-meter race, 4x1. And so what I want to do is I want to take the time for the world's fastest, 100 meters, which is 9.58. Usain Bolt from the 2009 World Championship event. I ran track, 400 meter, position when I was in ninth grade, or JSS3 they call it. And so I did that. I did 400 meters and 4x4. I did better in 4x4 though, in terms of the results that came out. As a team, we did very well. But anyways, enough of talking about past glory here. But let's talk about this example. If you want to convert the rate at which Usain Bolt ran 100 meters, if you want to convert that to something else that you can look at and think about and try to even go at that speed, let's do that, and then you'll see how math applies to conversion and how that's helpful in our world. So 100 meters in 9.58 seconds, right? And we're trying to convert this to miles per hour. So the first thing we do is we either convert the time or the distance. I mean, it'll be interesting to try and do both at the same time, but you really can't do that well. You have to take it one at a time. So let's take the time first. We know that 1 minute is 60 seconds. That gets rid of the seconds from this particular situation, right? 1 minute is 60 seconds, so that relationship has changed it. So now we technically have 100 meters and we can find our answer in minutes per minute. We don't have to worry about that though. We're gonna just keep creating a problem here. Then the next one is we're going to change that minute to hours, or to 60 minutes, 1 hour, right? So now we've changed the seconds to minutes and now to hours, so per hour, okay? Now we look at the distance portion, 100 meters. Why do we change that to like kilometers, right? Let's look at the meter-kilometer relationship. 1,000 meters, 1 kilometer, right? So we've canceled the meter portion and we have kilometers hanging out, waiting for us. And then how about we do one more step and change the relationship between the kilometer and a mile? So now, what is the relationship between a kilometer and a mile? 6214 miles. So 0.6214 miles. The relationship is 1 kilometer is to 0.6214 miles. If you look at this relationship now, the only unit that is left is miles per hour. So therefore, if you were to multiply the numerator, you would have, if you do all the multiplication in numerator, 223,704. And in the denominator, you would actually have 9580. Okay? So now we go ahead and simplify this, and the answer is 23.35 miles per hour. Okay, so we converted 100 meter, somebody's running 100 meters in 9.58 seconds. We've converted it now to miles per hour. So if you're driving your car and you get up to 23.35 miles per hour, that's the speed at which Usain Bolt is running essentially. Okay, now we can talk about wind speed and all that different time. But that's the speed at which he's running. But the interesting thing, of course, now, and maybe somebody has to do a study, is how long can you sustain that speed? That would be interesting. I don't know. That's another topic for another day. But it's just gives you some perspective of converting meters per second to miles per hour. Let me know if you have any questions, thoughts, comments. I just wanted to show another math real world application. Another one that is interesting is looking at the distance from the sun and then looking at the speed and converting the speed to a more usable form that somebody might be able to comprehend with everyday life. But that's another good example for rate conversions. We could do that at a different time. Thanks for watching.